So this is going to be lesson 2 out of unit 2. We're going to be graphing linear equations and inequalities using alternative methods. Actually, we're probably going to just work with graphing linear equations. We're not going to get into the inequalities at this time. So that's a good thing at this point. So out of this lesson here, graphing linear equations, there's going to be several ways of doing it. But basically, to graph a line, we just need 2 ordered pairs or 2 points. If there's a way to locate 2 points on the line, that's going to create the graph of the line by just identifying 2 of those solutions. So the first strategy is what we call finding the X and Y intercept. So when a linear equation is in what we call standard form, finding the X and Y intercepts is a great strategy to create the graph. So remember, to find an x-intercept, remember the y value was 0. So to find an x-intercept, we're going to set y equal to 0 and then solve for x. So remember, setting y equal to 0, this term will actually drop from the equation. So let's see if we can do that for this example here. So if I want to find the x-intercept, we're going to set, let's set y equal to 0. So that means we're going to replace y with 0. So this becomes 3x minus y, or minus 0 now, equals 5. So notice by putting 0 in for y, that term just drops out, and we're just left with the x term, 3x equals 5. So then if I just divide each side by 3, that gives us our x-intercept of 5/3. So 5/3 will be our x-intercept. As an ordered pair, that would be 5/3, 0. So sometimes we want an ordered pair, and sometimes we just want to say, hey, the x-intercept is 5/3. Now, to find the y-intercept, we do just the opposite. We've now set x equal to 0 and solve for y. Because remember, if to be on the y-axis, your y value is going to move, but your x value is going to actually be 0. So remember, by setting x to 0, so by setting x equal to 0, this term drops from the equation, leaving only the y term. So to find the y-intercept, we're going to set x equal to 0 this time. So I have 3 times 0 minus y is equal to 5. By setting x equal to 0, the x term drops out, and all we're left with is this negative y equals 5. Now, if we want to, we can call that coefficient a -1, and we can divide both sides by -1 to make the coefficient a +1. So it's going to be y equals, and 5 divided by 1, of course, is still 5. So all that really happens is the sign changes, and that makes that a -5. So that would be the y-intercept would be -5. As an ordered pair, that would be 0, -5. So if I want to graph the equation, to do 5/3, my x-axis is going to have to be in thirds. So I'm going to make little tick marks. So 1/3, 2/3, 3/3, 1/3, 2/3, 3/3, 1/3, 2/3, 3/3. So 1/3, 2/3, 3/3, 1/3, 2/3, 3/3, 1/3, 2/3, 3/3. So this would be 1 here, 2 here, this would be 3, this would be -1, this would be -2, this would be -3. Since my x value, but since my axis doesn't have any fractions or decimals, I can just make the normal tick marks without the decimals or the fractions involved here. So each one of those would just be a 1, a 2, a 3, -1, -2, -3. So 5/3, 0, well, that would be 1/3, 2/3, 3/3, 4/3, 5/3. So 5/3, 0 would be located there. And then 0, -5. Step out of the way. So the y-intercept would be -5. Looks like I need to go a little bit further on my y-axis. So I need a -4 and a -5. So there would be my y-intercept. So once we have those 2 points graphed, then we could just sketch the line by just drawing through those 2 solutions. So we draw a line passing through those 2 ordered pairs. And again, notice how I draw through those ordered pairs. So the line itself is made up of many, many ordered pairs. I've just identified 2 of the many, many solutions. And that's all we need is two solutions to graph a line, two ordered pairs or 2 points. Okay. So as we move forward, let's graph y equals -5x. When it's in this form here, again, I can make a table. And if I'm making a table myself, all I really need is 2 points or 3 points if I want to just double check myself. So if I'm choosing my own x values here, if there's not any fractions involved, I'm just going to use 0, 1, and 2 as my x values. So when I put 0 in for x, -5 times 0 is just going to be 0. So when x is 0, y is 0. If I put 1 in, that's going to be -5 times 1, which is going to be -5. So we have 1 gave me -5. And 2, that'd be -5 times 2, that would be -10. So I have 2, -10. So let's start to push it a little bit out there on my graph. So I'm going to try to make some tick marks here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then on the y-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. May have to make them a little bit closer together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0, 0 would be located, if I was graphing my line here, 0, 0 would just be the origin. 1, -5, so 1, 1, 2, 3, 4. -5 would be about here. And 2, -10, so 2, -10. That's the last mark we did. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that looks good. So 2, -10. So again, we have 1, 2, 3, 4, -5, -6, -7, -8, -9, -10. So it looks good. So if I draw my line, I can't draw very good with my pen, so I'm going to just use a tool here to do that. I think y'all have a tool as well on y'all's. So your line would just pass through those 3 points. And again, I didn't have to draw 3 points, but it's a good idea to make 3 to get an more accurate graph. So some things to pick up on our table, though, is notice how 0, 0 was our y-intercept. Also, if we look at this, we have the change in the y, the x's is a 1, and another change in the 1. If you look at the y's, they're decreasing by 5 each time. So this is called our rate of change. And the rate of change is defined by the change in y over the change in x. So that delta symbol kind of stands for words change in. So my slope would be, or my rate of change would be a -5 over a 1, which would be the same thing as a -5. So notice that the number in front of the x is our rate of change. If I, because if I put -5 over 1, that would still represent the same thing. Notice that the y-intercept was 0. Notice if we add a 0 out here, that's kind of what's happening here is the y-intercept is going to be this little constant out here, which we don't have. So what we start to build up on is, rate of change, we're going to be using this word slope. So slope and y-intercept are going to be another way to go about graphing it as we move forward. So if I look at this next equation, what we're seeing is in algebra, if the equation is linear and it's solved for y, the coefficient of x, the number in front of the x, is called the slope, which is going to define the change in y over the change in x. And the constant out here is going to define the y-intercept. So what I can do in this problem right here, if I want to graph y equals 2x plus 1, I can make a table, but our goal is to actually go from equation to graph. So really, our goal is to ultimately get away from the table. So what we should pick up on is this m is going to be this 2, or 2 over 1, if you will, and our b is going to be this 1. So the m represents our slope, or our rate of change. So that's going to be our slope, which is going to again be the change in y over the change in x, which we also call rise over run. So notice that slope is this ratio rise over run. And the b equals 1, that's going to be our y-intercept. And again, a y-intercept is a point on the y-axis. So that would be like 0, 1 as ordered pair. So we should be able to pick up on that information. So if I go over here to my graph, I can see that I can make some tick marks here. Don't need many. Just make a few. There's not much going on with this graph here, so we don't have to do a ton of it. So that's how my y-intercept was 0, 1. So at that point there, notice that my slope is the change in y, the change in x. So from the y-intercept, if I rise up to run over 1, notice how I can make another solution, and that will create the graph of my line. So your line would go through those two order pairs. Now, if I wanted to, I could have made a table. So again, if I use a table, I like to use like 0, 1, and 2 as my order pairs. So again, my equation was y equals this 2x plus 1. So that's how I'm going to be putting a value in for x. So y is going to equal 2 times 0 plus 1. Well, that's going to be 0 plus 1, which is going to be 1. So 0, 1 would be my first order pair. And also on our graph, we have graphed our first order pair was 0, 1. So when x is 1, if I look at that solution, y equals 2 times 1 plus 1, we end up with 2 plus 1, which is 3. So 1, 3 will be another solution. If you look at my graph, we already graphed 1, 3 using the slope. And I could also pick 2. So y would have been, 2 times 2 plus 1. That would have been 4 plus 1, which would have been 5. So 2, 5 would have also been a point. So 2, 5 would have been like, so if I stretched out my graph a little bit more, 2, 5 would have also existed. I would just have to extend my graph a little bit further. So what our goal is in graphing sometimes is to eliminate the table by taking advantage of some things that are actually in the equation. So to graph, if we know the y-intercept and slope, we can bypass the table and sketch our graph. So again, this slope is this change in y, this is change in x. And like I said, m is a lot of times the letter we use for slope, and slope is this rise over run concept. So again, notice how in our graph, when x is 0, y equals 1, that was going to be our y-intercept. So when you have this equation y equals 2x plus 1, notice how that b was the y-intercept. So it's easy to graph equation when it's in the form of y equals mx plus b. So if I look at this equation here, y equals negative 2/3 x plus 1, notice how this is in slope-intercept form. Notice how this y equals this mx plus b. So my b is actually this 1. That's going to be my y-intercept where it crosses the y-axis. And my slope is going to be the m, which is that negative 2/3, which again is my rise and my run. If I'm using graphing, those are important to me. So to graph this, we can make some tick marks over here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So usually that's enough to sketch these graphs here. So when I graph it, what we're picking up on is the y-intercept is at 1, and my slope is, my rise is -3 or -2 over 3. So my rise actually means from the y-intercept to go down to 1, 2, and then run over 3 to the right, 1, 2, 3. That would be my next solution. Now, the negative 2/3 could also have been 2 over -3. So if you wanted to, from the y-intercept, you could have rose up 2 and ran over 3 the other way, and that should still be on the same line. So those points should line up. So that's how we can graph a line by just I'm going to do a little bit better than that. Try one more time. That's a little bit better. So y equals negative 2/3 x plus 1 is going to represent, it's going to be represented by this graph. Again, the graph, I've only identified 3 solutions, 3 points. The graph itself is made up of infinitely many points as we do this. So some things to pick up on in the graph is also, so this has what's called a negative slope. So one thing you can pick up on is as you're going from left to right, if your graph is going down, this is considered a negative slope. So notice how as we move from left to right, the graph is going in a downward motion, or we call that a decreasing motion, or we also call that a negative slope. So if we look at the equation y equals 5x minus 3, if we want to graph this, notice how this is in perfect form to identify the slope and the intercept. So notice how we have this y equals this mx plus b. So notice how my b is this time is a negative 3, and my m is a 5. Now, to use it, though, we need a 5 over a 1, because we need this rise over this run to actually apply it to the graph. So in making my graph, we need some tick marks to start with. Again, this is the x-axis. This is the y-axis. So making some tick marks. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's see if that's enough to get this graph here. So the y-intercept would be negative 3. So if we pick up on that, our y-intercept is going to be this negative 3. From there, we have to rise up 5 and run over 1. 1, 2, 3, 4, 5, run over 1. So yeah, we have plenty of tick marks to get this thing in. So that would be the sketch of our graph using just those 2 ordered pairs. Oops. It's my little pin there for some reason. So that would be the graph of my line. Notice as we move from left to right, the graph is actually going up. So this is considered an increasing slope, or what we also call, say, positive slope. So, sometimes it's easy to plot your points wrong. So if you go back and look at the coefficient, if it's a positive slope, your graph should be rising as you go from left to right. If it's a negative slope, it should be going down if it's a negative slope. So it should be decreasing. So if I want to graph y equals negative 4x, notice how I just solved for y. So we have this y equals this mx plus b. Notice that there's no b. Well, that's because it's actually just going to be a 0. So we don't put plus 0 here. So y equals negative 4x really just means negative 4x plus 0, but we don't write the 0 in simplified form. So our b is actually just 0. In other words, it's the origin. And our slope is going to be this negative 4. So we can write this as negative 4 over 1. So because we need our rise and our run to actually graph it. So to graph this, then we need some tick marks. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So again, our y-intercept was just simply 0. And our slope is going to be down 4 over 1. 1, 2, 3, 4 to the right 1. Now again, you could have also wrote that as 4 over negative 1. So you could have also rose up 4, 1, 2, 3, 4, and left 1. And you should still be on the same line. So that negative doesn't matter where it is, if it's on the top or the bottom. So just got to pay attention. If it's negative, it goes down. If it's on the top. So we kind of get that going on there. All righty. So if I want to graph y equals 3, we should recognize that in the form of, y equals mx plus b, what's missing is the x. So what this really is y equals 0x plus b. So it does have a slope. That's 0x plus 3, I should say. Oops. So 0x plus 3. So notice that there is a slope to this equation. We just couldn't see it. So the b is going to equal 3. The slope is going to be, the coefficient of x is actually 0, because if x is 0, or if the coefficient of x is 0, the x term drops out of the problem, so they don't show it. So it's just understood to be there. So our slope is going to be 0. So that'd be 0 over 1. So there is no rise, there's only run. So that's kind of an indication that this is going to be horizontal, like we talked about earlier. This is going to be a horizontal line. So if I graph this using some tick marks, so the y-intercept would be 3. So that would be here. And there is no rise, there's only runs. This means we draw a horizontal line. So the graph kind of just goes from left to right. So really all we need is 1 point on that one and just kind of go up. If you need an extra point, you could just do run over 1 and call 1, 0, 0.2 if you wanted to. So if I have 2x plus y equals 1, an easy way to graph this is just find the x and y intercepts, since I need just 2 points. So the x-intercept, what we did is we can set y equal to 0 and solve for x. So remember, when I set y equal to 0, the y term drops out, so this just becomes 2x equals 1. If I divide both sides by 2, we get x equals 1/2. To find the y-intercept, we set x equals 0. That means the x term drops out. We just have y equals 1. So if I sketch this out here, so I need half marks. So I'm going to have 1/2, 2 halves. So 1, 1/2, 2 halves, 2, 1/2, 2 halves, 3. So make me some little half marks here. 1/2, -1, 1/2, -2, 1/2, -3. The y scale doesn't really need any half marks, so I'm just go ahead and just make my normal tick marks there. So my y-intercept, my x-intercept is 1/2, so that would be here. And my y-intercept would be 1, that would be here. So then I could just draw my line through those two ordered pairs to get the graph. Try it again. So there would be the graph of my line through those 2 points. So we also could use a graphing calculator to graph the equation of a line as well. So if we take a look at this problem, we have y equals 0.3x plus 0.5. So I could type in using the y equals button. I clear that off. I can put this 0.3x plus 0.5 into the calculator, and I can graph it. And I don't see much graph. Well, my window must be messed up, so let's hit the window button. Let's just change this back to a standard window, number 6. And what else we got on here? Y equals, oh, I got this plot stuff on here too, so let's turn that off. All right, let's hit the graph again. That looks a little bit better. So sometimes things get messed up. So from there, it says find y when x equals 0.4. So what I can do is work on my table, look at my table. Notice that I don't have 0.4. All I have is 0 and 1. So what I can do, though, using the table set button, above window, there's table set. what I can do again is start at 0. I could change my table to go by 0.1. And I can hit the table again. And notice how 0.4 could now be located at 0.62. So that's 0.62. Another thing you can do also, if you get your table set, you can also do your independent variable stands for your X. I could change it to ask. So now if I go to the table, it's saying, hey, what do you want for X? Well, if I pick 0.4 for X, hit enter, it'll give me that 0.62. So I can do all that, or if I want, I can just use your calculator and go 0.3 times 0.4 plus 0.5. So if I do that, oops, that's not 0.5 though. So 0.3 times 0.4 plus 0.5. Notice how it does give me 0.62. So you actually can just replace X with 0.4 and just do it that way as well. So there's a couple ways to kind of play with the calculator on this. So just give you some ideas moving forward. So the next question we have is kind of an application. So the cost of printing a magazine is $5,000 to typeset and prepare copy for printing. And then it's going to be $3 per copy to print. This is expressed as an equation, y equals 3x plus 5,000, where x is the number of copies printed and y is the total cost of printing x copies. Find the cost of printing 10,000 copies, then find the cost of printing 30,000 copies. So y equals this 3x plus 5,000. We should recognize that that is a linear function. And again, we could be using the calculator for some of this if we wanted to, or we can just do some stuff by hand. The 5,000 represents our fixed cost because it's going to cost 5,000 regardless. But then we're going to be charging $3 per copy. So X is going to be the number of copies, and Y is going to be the cost. So this is the cost over here, and this is going to be the number of copies over here. So we have this formula that will actually calculate cost of printing if we know how many copies. So notice the first one says 10,000 copies. So this would be y equals then 3 times 10,000 plus an additional 5,000. So this is going to be 30,000 plus an additional 5,000. That's going to be 35,000. So it would cost $35,000 to do that. The next one said 30,000 copies. So if I do y equals 3 times 30,000 copies plus 5,000, so that's going to be 90,000 plus 5,000. So that would be 95,000 would be your total cost for printing. So that's how some applications can work as well. So let's hope you find that useful as we move forward. So another thing we have going on is solving equations using the graphing calculator. So if y is equal to 0, the equation becomes a one variable equation and can be solved for x. Also, since y equals 0, the answer represents the x-intercept. This can be called what we refer to as a 0. So if I look at this equation, right now, notice how we have 3x plus 7 is equal to 2. Notice how right now this would represent your y value. But now if I subtract 2 on both sides, like this, I can create a new equation where I have 3x plus 5 is equal to 0. So what I can do here is I can actually graph y equals 3x plus 5. And what happens is I'm looking for when y is 0, that would be what we call a y-intercept. So let's see if we can put this all together. So if I hit y equals, and if I change this to 3x plus 5, let's clear that all up, 3x plus 5. If I graph that, the x-intercept would be the answer to this equation. Now, an easy way to find that x-intercept is if I go to calculate, second calculate, number 2 represents an x-intercept or 0. So if it says left bound, what I have to do is I have to move left of the x-intercept, hit enter. I have to move right of the x-intercept, hit enter again, and that gives me this negative 1.667. So that'll be our answer. X would equal negative 1.667. Now, of course, we could just subtract 5 on both sides over here. 3x equals negative 5. Divide both sides by 3, and you would have negative 5/3, or that would be negative 1 2/3. So I take it that negative 1 2/3 is the same thing as negative 1.667. So that's how we could have solved this equation by graphing if we wanted to. So if I want to solve this equation using the calculator, what I can do is kind of set one side equal to 0. So as we move through this problem, we have 3x minus 1. What I can do is multiply the 4 through the parentheses, 4x plus 8. I want to get the x on one side, so I need to subtract the 3x on both sides, pick on the little guy. So we then have this negative 1 equals this x plus 8. Add 1 to both sides, and we have 0 equals x plus 9. So if I wanted to, I can graph this y equals this x plus 9. So use my graphing calculator, we have y equals, then we can clear this off and hit x plus 9. And then if we hit the graph, I do see the x-intercept, so I have enough of the graph here. So now if I want to find the x-intercept, hit the second calculate. Number 2 is 0 or x-intercept. Left bound means to be left of the x-intercept. So I use my little like some people call it a little spider, move my spider left, hit enter to lock it in, then move to the right of the x-intercept or the 0, hit enter again, and it'll give me my x-intercept of negative 9 on the graphing calculator. Of course, we can also see that by just subtracting 9 on both sides and getting x equals negative 9. So there's just some relationships that we may be able to pick up on as we move forward in using the calculator. All right, that concludes my lesson on graphing lines using slope and intercept a little bit more. I think that's about all I wanted to do there. Let's see. Yeah, so we're just graphing linear equations. We didn't get into inequalities. Take care.